from them over the formation world and the solar system. The thing is, what's especially interesting about the meteorites is that they come from interplanetary space, but they consist of the same chemical elements that are in matter originated in Earth, and just in different proportions. But that makes it really identify something as a meteorite as opposed to just terrestrial rocks. So to talk about where meteorites come from, we need to talk about comets and asteroids, which they are basically made of debris left over from for 6 billion years ago. Now I'm going a bit out of real here. Not going to any depths on the comets and asteroids now. But I will comment later on that. For now, I will just cover some basic info about it. Okay, comets and asteroids. It might help we will think of. Remember we talked about the two crushes of planets in our solar system? They have different terrestrial matter like Mars and Earth, composed metals, and large gas giants like Jupiter. Now the solar system also has two analogous classes of objects, smaller than the planets, namely asteroids and comets, relatively near the Sun and in the solar system, between Jupiter and Mars to be precise. We got the asteroid belt, which contains about 90% of all asteroids orbiting the Sun. These asteroids are like the terrestrial planets, and they're composed mostly of rocky materials and metals. Far from the Sun, in the outer solar system, beyond Jupiter's orbit, temperatures are low enough to permit ices to form out of water, and out of gases like methane and carbon dioxide. Loose corrections of these ices and small rocky particles form into comets. So comets are similar in composition to the gas giants. Both comets and asteroids are typically smaller than planets, and even smaller type of interplanetary debris is meteoroids. And it's from meteoroids that we get meteors and meteorites. Right, when these enter the atmosphere, well, that makes them so special they get a special name. They are called meteors. Most of them are very small and they burn up soon after entering Earth's atmosphere. The larger one that makes it through the atmosphere and hits the ground are called meteorites. So meteorites are the ones that actually make it through. Now we've been finding meteorites on Earth for thousands of years, and we've analyzed enough of them to learn a lot about their composition. Most come from asteroids, though a few may have from comets, so essentially they are rocks. Like rocks, they are mixtures of minerals. They are narrowly classified into three broad categories: stones, stony ions, and ions. Some meteorites, which we refer to simply as stones, are almost entirely rock material. They actually account for almost all the meteor materials that falls to us. But even so, it's rare to ever find one. I mean, it's easier to find an iron meteorite or a stony iron. Anyone guess why? Look at the name. What do you think iron meteorites consist of? Mostly iron? Here, iron and some nickel, both of which are metals. And if you are trying to find a metal, oh, metal detectors. Right, thank you. Meteorites that's part of it. Stone meteorites, see they're around exposed to the weather for a few years. Well, they're made of rock, so made of looking indistinguishable from common terrestrial rocks when originated on Earth, so it's hard to spot them by eye. But we can use metal detector to help us find the others, and they're easier to spot by eye. So most of the meteorites are in collection and in museums there be the iron meteorites or the stony iron kind, even though they only make up about 5% of the meteorite material on the ground. 雑念が入った。もっとちゃんと集中してやるべきや。はい。Okay, I want to go over the different types of meteorites or what we've learned from them about the formation of Earth and the solar system. The thing is, what's especially interesting about meteoroids is that they come from interplanetary space, but they consist of the same chemical elements that are in matter originated in an Earth, just in different proportions. But that makes it easier to identify something as meteoroids, as it opposed to just terrestrial rocks. So, to talk about where meteoroids come from, we need to talk about comets and asteroids, which they're basically made up of debris left over from the origin of the solar system 4.6 billion years ago. Now, I'm going a bit out of border here. I'm not going to go in any depths on the comets and asteroids now, but we'll come back later and do that. For now, I'll just cover some basic info about them. Okay, comets and asteroids. It might help if you remember, we talked about the two classes of planets in our solar system and how they differ in composition. The terrestrial planets, like Mars and Earth, compose largely of rocks and metals, and the large gas giants, like Jupiter. Well, the solar system all has two analogous classes of objects smaller than planets, namely asteroids and comets, relatively near the Sun and in the solar system between Jupiter and Mars to be precise. We've got the asteroid belt, which contains about 90% of all asteroids orbiting the Sun. These asteroids are like the terrestrial planets, and they are composed mostly of rocky materials and metals. Far from the Sun, in the outer solar system, beyond Jupiter's orbit, temperatures are hmm, low enough to permit ice sheets to form out of water and out of gases like methane and carbon dioxide. Loose collective of these ice and small rocky particles form into comets. So comets are similar in composition to the gas giants. Both comets and asteroids are typically smaller than planets, and the even smaller type of interplanetary debris is meteorites. And it's from meteoroids that we get meteors and meteorites. Roids are, for the most part anyway, there are just smaller bits of asteroids and comets. When these bits enter Earth's atmosphere, well, that makes them so special that they get a special name. They are called meteors. Most of them are very small and they burn up soon after entering into Earth's atmosphere. The larger one that makes it through the atmosphere and hit the ground are called meteorites. So meteorites are the ones that actually make it through. Now, we've been finding meteors on Earth for thousands of years, and we've analyzed enough of them to learn a lot about their composition. Most comes from asteroids, though a few may have come from comets. So essentially, they are rocks. They are rocks, and like rocks, categories: stone, stony ions, and iron. Stone meteoroids, which we refer to simply as stones, are almost entirely rock material. They actually account for almost all of the meteorites material that falls to Earth. But even so, it's rare to even find one. I mean, it's easier to find an iron meteorite or a stony iron. Anyone guess why? Well, look at their name. What do you think iron meteorites consist of? Mostly iron? Yeah, iron and some nickel, both with their metals. And if you were trying to find metal, metal detector, right? Thank you. At least that's part of it. Stone meteoroids, if they lie around exposed to weather for a few years, well, they are made of rocks, so end up looking almost indistinguishable from common terrestrial rocks, ones that originated on Earth. So it's hard to spot them by eye. But we can use metal detectors to help us find the others, and they are easy to spot by eye. So most of all the meteoroids So most of the meteorites and corrections in museum, uh, there be they are meteorites, the stony iron kind. Even though they only make up about 5% of the meteorites material on the ground.